Hello. I would like to fix a problem that I noticed last time that I didn't handle. So the purpose of last time was the last thing we tried to do was to get all of the printing logic outside of the generation logic for the line stats and kanji distribution data. And I actually did not do that. So there is a qsort call here which sorts the data before it prints it. And so this is not what we want. And we also want this to be const, right, in order to prove that we are not changing it. Now, this KD is only needed, the kanji distribution, the kind of parent of line stats, is not only needed because we're trying to check whether we should sort it, but we don't really need to do that here, do we? So we can actually remove this argument and just take line stats, and we can sort it out when it's called, right before it's called, rather. So we end the line there, and well, we could do it in end line. That makes sense, right? Because end line is now we changed the naming convention. Before end line was printing stuff. Now it's only calculating stuff. So at end line we can just do this. And there. Okay. So now we're sorting it in end line rather than in the printing function. And print line stats. We no longer need KD here. Print stats summary. Okay. Now let's try that. Okay, good. So I'm going to go ahead and amend the previous commit. And that is good. Okay. Now, I guess what we can try to do is start to move the kanji distribution stuff generation to a new module for reuse. Okay. Now we can go to, let's see, we want to go to the make file, I think. Let's go to the make file and add this new kanji distribution file. And let me compare this to make map. So yeah, make map, we when we want to compile a new file, a normal reusable library file, we don't put it anywhere else except for in the shared sources list. So let's go ahead and open kanji distribution.c, a new file. Actually, I guess we want to do h, right? Okay. Struct line stats. All right. And what kind of now what kind of header files do we need for this? I see that we're using kanji entries, so we need kanji db, and we need rank. Let's see, we need romaji.h for the kanji key count. I think that's all the symbols we need. Let me look at romaji.h really quick. Yeah, kanji key count is here. So also one thing I would like to fix is I want to change the naming of these variables, or the integer types, to be more specific or more portable across like different compilation platforms. So I'll change unsigned short to what I really wanted, which was a 16-bit type, and this is a key character. Okay, that really is a char, and this is an 8-bit type, and this is a offset to target. So this really is a int16 type. Okay, you don't put signed, you just leave the s out. Okay, and then cumulative offset. Um, I guess this is like int 32 type. And so unsigned char uint 8 type. Kanji distribution uint 16 type. Okay. And that looks good. Now we need to include kanji distribution here. And we need to add the generation function, right? So we'll do, I guess we'll call it void populate kanji distribution and struct kanji distribution kd. All right. And we don't have a function called that, but we're going to create one. We're going to pull it out of print last strings contained parsed args, I guess. And yeah, that looks pretty good. Maybe we should just make sure this compiles. We have to add a kanji distribution dummy file first. Kanji distribution dot h. All right. And we'll make this uint 16 type. Oh, I guess uint 16 type is like is declared in standard int or something like that. Uint 16 type. Or maybe it's not. Maybe I'm confused and this is not like a C thing. It's only in C++. Because Vim is highlighting it, which kind of makes me think that it's a keyword. So I shouldn't have to include anything. But let's try this again. Let's do, okay, grep type, types, state types.h, bits/types.h, I guess. 16, no, but this is underscored. Alpha half 32. Okay, so this file uses it. Let's see what it's including. Features.h, standard int.h. I guess that's what I want. Yeah. Oh, wait. Standard int.h. Let's try it. So grelin is something that greps a little shortcut I have that greps the Linux system header files. Well, I don't think it's going to include kernel header files, but it's going to include standard include files. Standard int.h. Let's try that. Okay, good. Now, we got to figure out what functions we need to move. And I'm guessing it's going to be most of these functions, except for perhaps the end line function and the print functions. First kanji in radso. I wonder if I use this functionality elsewhere, first kanji. Let me look for this. Git grep last strength contain.c, romaji.c. I guess not. Maybe I don't. Okay, so I won't move that function around, and this is used in the generation logic, so this is going to have to be moved. First key. Okay, let's go one by one. and see what we need to move. I'm just looking to see what is static, what static functions I have in here, and I expected that only one function would be non-static, and it's this one. So that's good. And let's see. We have end line. We need that here. All right, let's start from the top. First key, first strength less than hide kanji, and show per line kanji count. These really do need to be here. I'll put them here. These need to stay in this file. First strength and less than get top keys. So this by the way is a comparator for Q-sort or binary search. It compares the radical stroke count sort key, and then it compares the rank after that. Get top keys sounds not needed. Print line stats. Okay, I think all these need to move. Oops, wrong one. All right. Do I actually use assert? I'm surprised by this. No, I don't use assert. I don't think this is needed here. And print line stats. Okay, that's obviously going to stay. Print stats summary, that's going to stay. And this is going to move. Read user cutoff kanji. That is going to stay. Oh, this is a good question. What are we going to do with this function, read user cutoff kanji? Are we going to move that or not? Does that belong here because it's interpreting the command line, or does it belong in kanji distribution? So I'm guessing it needs to go into kanji distribution. Read user cutoff kanji. So so we put it into kanji distribution. Last string contain parse args. So probably what we want to do is we want to have more than one function here. Kanji distribution dot h. We're probably going to want to have have one function that automatically finds the sort keys, the likes, yeah. Automatically finds the cutoff points, and one that parses it for the user. So so we could do like kanji distribution auto pick cutoff. And I'm going to change the naming convention here so that the name of the struct comes first. That's more uniform. Auto pick cutoff, and find user, or parse user cutoff. And this will be int because there may be an error here, and this returns, or this takes a char cons char argv and an int argc. All right, and parse user cutoff. Okay, this is already getting more complicated than I thought it would. I'm a little disappointed in that, but that's how things are, I guess. And I didn't consider that I have to create these functions, auto pick cutoff and stuff. So how are we gonna continue? Now I wonder if this resorted thing is going to have to be part of kanji distribution, because now it's going to be used both before and after the parsing. Okay, so we sort it twice, and first is when we are doing this. So I'm seeing that we call qsort on resorted twice. Resorted is just all the kanji database kanji, but in a different order. And so it looks like here we use resorted for one thing in one order, and then here for another order. So that means we don't have to maintain it between these two functions, or between rather the auto pick cutoff and the populate function. We don't have to maintain the resorted array. So that means that kanji distribution does not have to be dynamically allocated. So that's good. Edit kanji. So let's take these functions and we will put them into the C file. Right. Okay. So we have those empty bodies there, function bodies. So resorted is so let's just add a comment, kanji distribution dot h. So first call auto pick cutoff or parse user cutoff, and let's see here, usage. First memset to 0, 2 call auto pick cutoff or parse user cutoff, and 3 call populate. All right. Now get top keys. Get top keys is going to be distribution dot c. So maybe we need to actually put get top keys into as a non-static and ask them to initialize that. Ask the user to initialize that first. Is target. So what do we do before we actually parse the cutoff characters? We or automatically find them. So first we get top keys, which finds the number of codes for each first character, for each like set of codes that share the same first character. And then we then we sort, and we start, and it looks like right after that we start to parse the cutoff kanji. So KD target rank resorted. Yeah, so we actually need this resorted. So we sort resorted, and we need this regardless of whether we call cutoff kanji or regardless of whether the user specifies a cutoff or we get it ourselves. So that's going to have to be in a shared function. And get top keys is like initialization before those two functions. So we'll call that like an initializer, I guess. Kanji distribution. Fine, kanji distribution dot h. And so I'm actually kind of thinking about something tangentially related, but how is the call site, or how is it supposed to be clear to the reader of the code that kanji distribution does not have any dynamically allocated stuff, and it could just be destroyed by going out of scope, and you don't have to call any kind of destroyer function, because that's kind of important, and it would be nice if this were clear, like if we added some kind of a naming convention like heap or underscore stack, which are bad names, but just examples. And these names would indicate whether or not we need to release the data afterwards. For now, I'm just going to put that at the back of my mind and think about that later. For this one, it's stack allocated apparently, and we don't need anything like that. So we say, let's say call init. All right, so void kanji distribution underscore init, and struct kanji distribution. But you know what? We don't have to ask the user to do that themselves. We can just do that in these two functions here, right? So set to 0. right? We can just do that automatically in these two, in both of these two functions. So let's say, okay, I think that we're ready to start writing this. So we can have static void conj distribution. Let's call it common init, right? So we'll set it to 0, and then we're going to call get top keys. Oh, but there might be flags in kanji distribution, right? So we don't actually want to initialize it to 0 because there are user given flags here. So we can't do that. So get top keys. Okay. Get top keys. And then we need to have the resorted function resorted. So so both of these two cutoff function or these cutoff functions need to get a resorted array, and so they are going to have to. Let's see here. They're going to have to do this. I guess we will have a resorted thing here. So it's called. So this common init will return the sorted thing. Const. So we have a construct kanji entry resorted. And this is going to be a pointer that we change. So maybe we'll type def this so it's easier to handle. And it is a construct kanji entry resorted, right? And here we'll do a resorted kanji. So what are we resorting them to? We're resorting them as these are sorted as I wonder if I should put what it's sorted as in the type name, but let's not do that. We actually sort it by the ranking here. But anyway, so we're going to get top keys, then we calculate resorted NR. Where is that used? Ah, interesting. So you know what? Let's do this. Let's use our util, our array calculation, like our array dynamic array resizing stuff for this. We'll call the struct resorted kanji db, and we will have a size t count and a size t alloc, and we have to use a certain kind of layout in the struct in order to use that macro. And we're going to have a this. Okay, sort of kanji db. And so okay, so now we're going to have an alloc grow by the resorted one and grow it to kanji db nr. Oh, but it's always going to be kanji db nr. That's always the size of resorted. So maybe we don't need this extra thing. Um, yeah, I don't know. It could really go either way, I guess. So we're going to alloc grow by, I'll just keep it this way because it's faster now that I've already written the code. And I don't like this kind of raw xc alloc. It's a little annoying. Uh, yeah, and at least this way we kind of have we automatically pass this value. Alloc grow by implicitly grows by the size, grows in increments of the size of the elements, which is good. So now let's see how we're going to do this. I guess we could do memset. No, we don't want to do that. We'll assume resorted is already initialized to 0. So alloc grow by, and we do what next? We're going to have to sort this stuff, resorted nr. So let's take this resorted nr. We're going to basically move this out. This is the common initialization stuff. C sort of nr. Let's just change this to I. For I equals 0, I is less than GDB. Yeah, we don't need resorted nr. Change word I. Sorted dash L. Oh, we don't want to name it this. We want to name it L. That's the naming convention we need. And so we do k. Let's see, resorted dash L and resorted dash count. And then we go down resorted A ranking, resorted B. Okay. We have to change the way we are using resorted now. Resorted L, target rank. Target rank is that line stats first kanji. We don't need this anymore. Resorted NR is not needed here, at least. Line stats. Line stats is not needed in this function, but it will be needed in the generation, the population function. So res equals 0. What is res for? Res is for parsing cutoff. Okay, parsing user stuff. Okay. Auto pick cutoff. So we have this common initialization thing written, more or less. Let's finish moving over functions that we need here. We need end line, find best cutoff, is better cutoff, read user cutoff kanji, print stats summary, print line stats. So I think we need basically everything here. Read user cutoff kanji, and is better cutoff, find best cutoff. End line. End line is generation logic. We do need that. And I grabbed some printing logic, didn't I? No, I skipped that. Okay. So end line. Okay. This goes into here, I think. So pick user, auto pick cutoff. Okay, so we have a struct resorted kanji db, resorted equals that, right? And we need that in both of these ones. And we call common init. It's kanji distribution address resorted, right? And we also need to call, don't forget to call array destroy, or is it called destroy array? I don't remember. util.h destroy array. Okay. Call it down here as well. And we have print line stats. Okay, kanji distribution parse user cutoff. All right, we're getting closer. So cutoff kanji count means the user is passing it themselves. Read user cutoff. So we can just inline read user cutoff into this function we just created, this initialization function. Read user cutoff kanji. Okay. Delete this. User cutoff. Return 2, return 0. Okay. So we have all these returns, and we don't want to, we don't really like that. So we're going to say res equals 1 and go do cleanup so that we can free the array. Res equal 2. Cleanup, okay. So then we have cleanup, destroy array, and return res. That can all fit in one line, but I'll leave it. Comment init, cutoff kanji count. Expecting the right kanji count, line stats nr, destroy array. Okay. Read user cutoff kanji, let's delete that. And let's rename the arguments. So cutoff kanji ra. Let's call that argv and argc. We still want to call it that. I guess we'll just keep that name because it does, from the name of the function we know what the arguments mean. Argv and argc are somewhat vague, but we actually know what they mean in this case. Now, parse user cutoff argv, argc. I'm just wondering if I use the same consistent ordering for argv and argc. Yes, I do. Okay. This is looking good. And ra, where's this thing? Cutoff kanji ra. We're calling it argv. 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 Okay. And cutoff kanji count. Argc. Oh, argc. Okay, kanji db. Oh, we need kanji db here. I didn't include that. I'll include kanji db.h. Okay. And we can call changes to xfprintf now. xfprintf. And okay. That looks good. Line stats, I+1. Destroy array. Okay. And now auto-pit cutoff is going to be here. We can delete this. Let's say, but now we can kind of make this a little bit simpler. We can call this kanji distribution parse user cutoff, and we pass cutoff kanji. Yep. If res, then we can return it. We don't have any cleanup anymore. So if res, return res. Okay. And now we take this. This is the automatic cutoff thing. cutoff logic, cumulative offset ki, resorted, nr, so sort key. Wait a second. Oh, we need resorted here. Interesting. Ratso sort key. We have two calls to qsort. Comment init, alloc grow by. Okay, I thought that there was only one qsort up here. Now I see there are two, or there was two. So I'm sorting by ranking here, and then sorting by radical stroke count here. So resorted -L, why are we even using resorted at all here? Resorted L. Let me look at the code. GitHub add for new sort, because I've confused myself. I'm going to look at older code and go to rank coverage, kanji, last rank contain .c. Okay. So we last rank contained parsed args. Okay. So how are we doing this? We have qsort here, and we're using resorted. Oh, maybe we were never using resorted. Resorted. Parse. Oh, I guess we never needed this. This should have not. No, we're using it here. Chars equals ranking. So this, the purpose of this is to find ranking. Why is that? Oh, okay. Okay, so so the thing is, resorted does not have everything in kanji db nr. It's actually kind of, it's less than that. It has the ones that we don't include in, it removes the kanji that we include in the hard-coded mappings. And it also removes characters that have a high ranking, overly high ranking. So then we resort it, so this is how we find the target rank. Okay, interesting. Interesting. So resorted really should be used kind of in this way. So is non-sorted string or that, then we continue, right? Otherwise, we do grow array by, what's it called? Grow array by resorted. You call it grow array by 1, then resorted -L, resorted -count -1 equals E. Okay. All right, we've kind of saved ourselves. Then we really do need to resort it here. So guys, guess -element resorted -count. This was a strange way to indent. All right, good. I guess last time the code was in here, and so I couldn't just include couldn't include the comparator all in a single line. Qsort common init. Okay, this is looking good, I think. Current cutoff kanji count. Size t. Size tki. Oh, we need to keep this. We don't want to reset it each time. Okay, I equals 0 and cut off I, or cut off, let's just keep the name count. All right. KD line stats. Okay. Yeah, this is involved, but it's looking better. Now I don't think we need any of this. So if cutoff kanji count, then we parse the user cutoff. Otherwise, we kanji distribution auto pick cutoff, give it KD. Okay. And then we populate kanji distribution populate, and that is going to have all of this logic and line. All right. Now, do we need size ti in here anymore? Yes, we still need it. We need line stats. No, don't need that. Let's move this into populate. It's probably needed there. And res is not needed at the top. Turn 0. Okay. Now, I don't know if I want this function anymore, because really it's not doing a whole lot. I think we can just inline it at this point. So let me move size t here, and return 0. Okay. See argv, argc. Oh wait. Yeah, argc, argv. Or no, it's argv, argc. argc. And we are incrementing argc and argv, so that means that by the time we get down here, it is already correct. So line stats nr. Okay. So we don't need this. Good. Kanji distribution. Okay, we're getting close. I don't think we're going to have any nasty bugs like last time. So that's good. Line stats and resorted. So now we need resorted for another reason here. So I think we need to get this and put this into a common function. And unfortunately, we're going to free the array between function calls, but I think that's fine. It's simpler to write the code that way, and it's not going to it's not going to really increase the runtime complexity exactly, because we're just going to, instead of allocating once and resorting several times, we're going to allocate once and resort each time several times, and or 2 or 3 times. And allocating and initializing it before sorting it is really just order of n complexity, and sorting it is more than that. It's n log n, or yeah, I believe it's n log n, and so that should be that should not increase the complexity. I mean, in terms of big N order, like on big O complexity. So I guess that's fine. Now we'll have static. Where was I? Okay, static void populate non-hard coded, right? And it is in a resorted array, right? Oops, sorry. Still want this. Populate non-hard-coded, so we're going to populate this array, and it's really as simple as doing this. So size ti non-hard-coded resorted. And I guess we don't really need. Now, I guess we don't actually need to return this from comment init anymore, but maybe we'll just do it anyway. Qsort, auto pick cutoff, user cutoff. We don't parse user cutoff. We don't need it. We're not using resorted. Oh, so because we're not using it, we can just free it right here. We don't need the cleanup logic. Return 0. And okay, return return okay. Destroy array resorted. Okay. So now in populate, we're going to get resorted. We're going to have to use resorted again. Struct resorted kanji database. Is that what we called it? Yes. Resorted equals. Now I need to make sure that I initialize it every time it's initialize the 0. Okay, good. And we're going to do populate non-hard-coded resorted. Okay. Then we sort it, and we have to delete this at the end. So array destroy array resorted. All right. Does this build? No. Okay. Distribution is set but not used. Last rank contained. Print last rank contained. Kanji distribution. Oh, let's call it KD. Let's call this KD. Nah, well, let's not. Let's keep the diff clean. So kanji distribution. Oh, pick cutoff. Oh. There we go. And here is address kanji distribution. All right. Let's try again. I undeclared, line 241. Size ti, okay. And let's do a little bit more. util.h will ignore those. Go up, line 237. Okay, we're not using it correctly. Resorted. Oh, resorted.l and resorted.count. Then rank. Okay. Oh, .l. Probably gonna have to fix other instances of that. 256 line stats dash e line stats equals resorted dot l. Okay. Right. Again, 256. Pointer type. Resorted nr. Resorted. Why is it incompatible pointer type? Kanji DB. Is kanji entry not defined in kanji db.h? No, it is. Line stats dash e. Kanji distribution. I'm wondering why it's saying incompatible pointer types. Kanji distribution. So line stats dash e is kanji entry. Yeah, this should be fine. I don't see the problem. Let's fix some other errors. Kanji distribution.c. 50 go. Next error is this. Kanji, okay, 245. Resorted is not used properly. Okay, let's look for resorted. Okay, resorted is now used properly. 245. Didn't save it. Okay, try again. 242. Dot count. All right, 256. Still has an error there. 195, unused variable. And then 225, cut off. I guess what I should do is I should like compile it with warnings completely hidden and first, and then once that's compiled, I should compile it with errors, with warnings turned into errors. That would like allow me to prioritize better. Sum for incompatible pointer type again. Kanji entry. So that seems like it's a repeat of the error that we don't understand again. 5 go, cut off. 200 error. Oh, forgot this one. Commands.h to get the mockable stream handles. And okay, 184 resorted. Oh, okay. Find best cutoff. So find best cutoff could just take resorted the array. Resorted. It's yes. So find best cutoff can just take this struct resorted kanji db. Resorted. Looks like it was called K before, wasn't it? Yes, okay. Now let's move this definition. Find best cutoff. Oops. But maybe it doesn't make sense to pass it that way since it's not going to resize it. Maybe it should just be passing the element and the count separately. Oh well. K dash L. Okay. K dash L. All right. And then we have NR. So it's K dash count. That wasn't too bad. K NR. It's K dash count. Okay. Try again. 223, 181. Sorry, yeah, I still don't understand this. So some of these lines can be unwrapped. Good. 174 rank coverage reset. Okay, rank coverage. We need to include that. Rank coverage. Type resorted L 170 resorted. Resorted is no longer a, or it never was a pointer. Okay, again. Um, 171 resorted.l and .l. Okay. Well, I guess I should do it like this. There. That's a little bit more obvious about what the hierarchy of the expression is. And then 158. Okay, we're getting all these errors. I haven't been able to figure out yet. Redefinition of struct kanji entry. Oh, this is interesting. Kanji db.h kanji distribution. So it's being included in kanji distribution as well as kanji distribution.c. Okay, that may have had something to do with it. Good, that helped. So 79. KD undeclared. 79. Kanji last rank contained has an error now. Right, because we deleted a lot of stuff from it, so that would make sense. Last rank contained 76. Distribution populate. Alright. Alright. And then 79. Okay, that's not a pointer. And 69 is unused variable argv. It thinks I'm trying to declare a variable there. Okay, let's try building again. So that was a major syntax error. 78. Okay. KD kanji distribution dot stats nr. Last rank contains 67. Kanji count. This is actually argc. Okay. Good. It built, but I got a segmentation fault. Okay. Last rank contained test. Check kanji database order. Test quiet. That's like the first test in it, isn't it? Okay. Okay, so let's take a break. I don't want to do that printf debugging again. So I'm going to just kind of take a break here and figure out how I want to debug the segmentation fault, because I don't want to force everyone to watch the printf debugging again. I want to find a smart way to do it. So let's call it finish for now. But let's go over what we did. Edit new sort tasks. So we removed the sorting logic, which was some extra generation logic from the printing logic. And then we did a bunch of refactoring, and I believe we're almost done, except for the fact that there's a seg fault, and I must have forgotten to allocate an array properly or something of that nature. And so yeah, that's what we did. So we're kind of like 99% done with number 2 here. So maybe, yeah, I don't know if I'll end the video here or not yet, but let's just stop it for now. Okay, so I was a bit confused about the output, and I gave up just a second ago, but then I realized that I was running make in parallel with concurrent operations, and that was confusing. That was what was confusing me. So it turns out the thing that was seg faulting was actually not enough args, which should be relatively simple to debug, because that is not really doing a whole lot. So let's look in kanji distribution, kanji distribution.c, and we have not enough. So we're let's actually look at the test first. Last rank contain test, not enough args. Okay. Not enough args. We're just passing one. So if I run new sort and we pass it with one argument, new sort, last rank contained. Okay. I wonder if I can just run GDB like that. No debugging symbols found. I guess we want to do... Well, I'm feeling like if I just read the code, I'm going to figure it out faster. So let's just read the code. Kanji distribution.c. So we are... So this stuff should be fine. I didn't change that. So down here, we're checking if argc is on or off. Then we parse user cutoff. And we give it argv and argc. And we say resorted, comment init, resorted, populate non-hard coded, resorted. Okay, grow array by. Not resorted. I'm just looking for anything that looks like I am misusing. Oh, here we go. Or if ranking is that. That means we skip it. Okay. That could have been the cause of what was the seg fault. So ranking, got to make sure ranking is what I expect it to be. So kanjidb.h ranking. Let's call this a UN16 type. All right. And I don't know if that's defined in standard def.h. Let's see. Make one. No. Okay. Let's just commit that one as a separate entity. Oops. Let's see what I have here. Okay. And does this build? Let me make sure it builds. Make. Yes, and it passes. Okay, very good. So we're going to commit kanji database.h as a separate change. And this is going to be specify exact type, exact integer size of fields. And this kind of makes sense because this is supposed to be a highly packed field, like there's thousands of them in memory. And I do want to actually use the right one, use the right size for each field. And actually radso sort key, I believe, is 16-bit. I'm not sure why it's unsigned int. Let's fix that as well. Radso sort key. Radso sort key. Radso sort key equals I. Oh, I see. Because it's actually, we're actually incrementing it. Yeah, the reason is because we are assigning each character a unique sort key rather than doing it based on the cutoff point. So that's actually interesting. That may be something we want to fix. So we have 4,000 characters or so in the database, but these do not all have unique sort keys, right? Because some characters have the same radical and the same residual stroke count. But here we are assigning unique keys even to those, and that seems wrong. And it could be giving us unusual results when we're sorting, because everything is unique, right? And I believe we were sorting by radso sort key at some point, and then sorting by another key. But actually, I may have been wrong. It looks like we only sort by radso sort key and not by other keys. And in fact, this may be fine. Maybe this is fine. I think I'll change it. I'll change it in a different video, or I'll fix it in a different video. But anyway, okay. So I think we're almost ready to commit this change. Let's just do a quick review about what we've written. So we move a bunch of stuff into kanji distribution.c. Oh, you know what? We actually want to remove unused includes from here. There's going to be a lot of unused includes. So coverage, yeah, rank coverage is not used. Util may or may not be used. Commands is used because we're printing to these redirectable streams, and util, we can keep util, I guess. Standard lib and string. I don't think string is needed. And standard lib, I don't know what that was about. Let's see if it builds. Okay, maybe we don't need standard lib. And I don't think we need standard IO unless we change. We don't need it if we print it to using our utility methods. Right? So printf. Looks like we don't use normal standard IO functions, so we can delete this one. Okay. We do need util.h because we're printing with xfprintf. So let's build that and see if it works. Yes, good. Good. And I wonder, is there any way we can simplify this? Print stat summary is not super helpful, honestly. Print line stats. So yeah, I don't really know if I like these extra functions. They don't seem to be helping a whole lot, but I'll keep them, I guess, to keep the diff clean. And unsigned int radso sort key. Okay. And this builds, right? Everything's fine. Okay. Okay, so we added a new file to the make file, and that's the kanji distribution.c. And then we moved a whole lot of stuff into kanji distribution.c, which was from last rank contained. And we have pretty much unchanged code here. Get top keys is a strange name now that I think about it, because it doesn't really explain what it's doing. What it's really doing is it's figuring out the number of keys available on each line for each set of codes that have the same prefix. And calculating total chars is fine, I suppose. Is better cutoff. Yeah, none of this stuff is different from what was already in last rank contain.c, except for this resorted kanji db thing. And this was nice to use. It was nice to use the array, dynamically allocated array, for that, because it was like a little bit smaller than the kanji database, and so we didn't know the exact size of it. And so now we avoid calling xcalloc directly, which is a little bit easier to read, I think. Next offset. So find best cutoff is basically the same. It's automatically finding the cutoff point. And end line is the same. Populate non-hard coded is a new function which we use to find all of the kanji characters which are not in the Romaji map, which is this here, because we have some kanji which we treat as Romaji, and we another way to call them is hard coded because they're not kana. So comment init. Now I don't know if keeping resorted around really makes sense here. This feels kind of funny because it's not even used by both of the functions. So yeah, I just remembered I might want to change this before we commit. Destroy array, because now here we're destroying it like right after we initialize it, and at the other point that common init is being called, it's being used. Let's see here. So once it's called, it's just kind of destroyed right away. And in the other case, it's sorted by something else right away. And so it just doesn't seem necessary to keep that around. Common init. And I think that if we really wanted to avoid memory out like unnecessary memory allocations, we would simply put resorted into kanji distribution. We would not keep on we would not like pass it around in these functions like this. We would just store it as a field here and then just say that we need we need to free it when we're done. So here, let's delete this. We don't need it. Struct resorted kanji db resorted equals that. And then we want to say destroy array resorted. Okay. All right. And we're going to populate it common init here. Populate resorted at this point, right? And we no longer pass it here. Common init. Okay. Destroy. No longer need to destroy it there. Okay, good. And I kind of like that the fact that resorted is, I can keep track better now when I read the code of where resorted, how resorted is used and resorted over and over again. So we may not want to call it resorted. We may want to call it, give it a better name when it's easy enough. Resorted here refers to radical sort here. Oh, I don't think we need to even sort it here, because at this point when we populate it, it's already in the kanji database order, or is it? Edit kanji db.c. No, we resort it here according to the Unicode value. So the canonical coding, like in memory, once it's initialized, is by the Unicode value. So we do need to resort it here. And okay, maybe that's fine. No, resort 191. Okay, we don't need it here. 154. Resorted. Resorted. Okay. This is no longer a pointer, so we got to use it properly. No dereference. 168. Okay. Okay. Now this has to be passed like that. 151. Okay. Good. Okay. So that looks very good. So now this is what we wanted from the very beginning. We wanted to put the kanji distribution generation into a separate file, and we did it. And the code is actually a lot nicer now because I had a chance to think about it while I was refactoring it. And I think the fact that I was talking about it out loud actually helped me write it this time. Whereas when I originally wrote it, I was not talking aloud, and so I was not really observing myself very well. But this kind of made me a little bit more aware of my own decisions. And okay, I think that it's ready to commit now. So I'll just make a commit message here. It's going to be something simple. Write it in English first. It's like move kanji distribution. Oh, I actually already wrote the crappy commit message. It is in new sort tasks, and it is move kanji distribution generation to a new module for reuse. Right there. And I don't have to type that again for the video, so we can end it now. Thank you for watching.